on the matter of a tangent. So remember, we said that the tangent is the line that passes through one point of the circumference. And here, the tangent is the line BC. And the point of tangency, that's where the tangent touches the circle, is point A. Notice the angle that is formed between the radius of the circle and the tangent. Doesn't matter how long the tangent wants to be. Doesn't matter where the radius touch the tangent. Well, that is what really matters, where the radius touch the tangent. But that does not change the angle that is formed there. If you notice, I'm moving the angle and I'm moving the radius and I'm moving the tangent, but it all stays the same measurement, which is 90 degrees. So the radius, where the radius meets a tangent, a 90-degree angle is formed right here. So let us look at another example of this one, or something similar but quite different. So notice this chord GH, it is not a tangent because it's passing through or touching more than one point on the circumference. So this is just a chord. So the idea behind this theorem is that when you see a situation like this, it is saying that the line GI is equal in measurement and length to the line HI. Pretty simple. So it's saying that GI right here, so, and IH is the same length. No matter how big it is or how you want to turn it, it's going to be the same length. So it's almost as if this thing that wants to look like a radius but is not a radius is splitting the chord in two equal parts. Alright, so let's mix that one with the one before to get something new. Now this one, as confusing as it looks, is very simple and easy, and is a combination of what we've looked at before. Notice that there are some tangents, right? And wherever there are tangents, between a tangent and a radius, a 90-degree angle is formed. So for example, J, K, and M, you have a 90-degree angle. And there's also another tangent, right? QP. And it touches another radius, JN. So right in there, so you have another 90-degree angle formed. This one is interesting. Let me hide this. Notice too that the angle inside the circle right out here, so, is 141. And the angle that is formed out here, so, between the two tangents is 39. When you add 141 to 39, how much would you get? 180 degrees. And that makes sense, right? Because remember, there are 360 degrees in a quadrilateral. And if this one up here, say, is 90, and this one down there, say, is 90, that means you only have 180 left to share between the one up here and the one down there. Simple. So opposite angles in a situation like this add up to 180 degrees. We call them supplementary. And if you notice too, from T to K is the same length as T to N. Pretty much they're the same, or they're exactly the same. So that's it. And it doesn't matter how I want to turn it, right? It doesn't matter how I want to turn it. The principle remains the same. Once you have a tangent touching a radius, 90 degrees are formed between them. Tangent and a radius, 90 degrees is formed between them. And the angle out here, so between the two tangents, sums to 180 with the angle at the center of the circle, right? And that's it. On the